Player, I always play left-handed.
Are you ambidextrous or just?
I have trouble with my right elbow. I have tennis elbow. And every now and then, I think I've had 3 shots in it. I don't like getting shots.
I don't blame you.
I think it's not good to do, but so when it was really bad for about 2 years, I played left-handed for about 2 years. So I got to where I could play reasonable. I do downhill skiing. I have done cross-country skiing. That's not.
That's so hard.
My first experience cross-country skiing, unfortunately, was in the Rocky Mountains.
Okay.
And so I wasn't excited to try it again for a long time.
Yeah.
Surprise!
Going uphill the Rocky Mountains is way better than coming down. One of my friends with me actually went off a cliff. About a 20-foot drop.
Ooh, wow. Probably hurt.
And get hurt. It was all powder. Been more concerned about drowning. It's been a while, but I used to do bowling. I do play the guitar. I mess around a little bit with the piano, although I'm not very good at that. Puzzles. I have lots of puzzles, mechanical puzzles, and of course I do ride a motorcycle.
I'm surprised you didn't bring the bus today.
Yeah, I probably should have. Probably should have. Business background. Again, I did a lot of things as a young person. When I was in high school, I worked at Fisher's Cheese. I was considered part-time. I think that meant I worked usually under 40 hours a week while I was in school. It's usually somewhere between 30 and 40. When I finally got out and went to college, I started working at a company called Triplet. When I graduated college, I went to work for Triplet. I was a programmer and or systems programmer there for about 8 years. During that time, I was also an instructor at a couple of different junior colleges. And then I worked full-time at a junior college in Georgia.
What part of Georgia?
Douglas, Georgia, Southern Georgia, South Georgia College. It's about another hour to get down to Florida.
I lived in Augusta for a while. So
Okay.
I was curious.
The Okefenokee Swamp was about half an hour, 45 minutes away, due east. And after that, I came to Lock Haven University, and I've been here 29 and a half years. During that time, I did some consulting and programming other places. I did a textual database for hazardous waste hauling of material, and a few other things. I left for 4 years and went to Mississippi State University. I came back for a year and went back to Mississippi State for another year. I was a research assistant. I did work at the Waterways Experiment Station called WES, Digital Instrumentation and Analysis Lab, and finally the Stennis Space Center.
That's good.
Yeah.
Very cool.
Stennis was my favorite by far. When I was doing the work at Dial, we were doing artificial intelligence to identify hazard waste containers. Specifically, they were worried about radioactive waste. And I did not want to be affiliated with that, so I was really happy to get out. Stennis, we were doing unsupervised learning to identify the contents of the ocean floor from very poor quality pictures.
That's neat.
We were identifying sand waves and different clusters. They were really interested, I think, in being able to identify rooms.
Now, how far down did you guys actually get?
I was never in the ocean doing it. I only
Yeah.
dealt with the,
How far did like the pictures proceed to be?
well, they were sonar pictures.
Okay.
So I don't know the depth, although I think it was on some, first time I went to Stennis, and they were walking us back through the lab, all these people, these great big CRTs, all these people would lay across them because we weren't supposed to see what was on them. And after about our fourth time, they stopped doing that. They figured we were wrong.
It's cute.
My last year when I was in Mississippi, like going back down, I was a senior software engineer consulting for Department of Energy for development of middleware for high-performance computing. So we were dealing with 3 different labs, 2 of them in New Mexico and 1 in California. And that was a very interesting project. Jeremy?
Do you recall which labs that you worked with?
Lawrence Livermore National Labs in California was a big one. They had a lot of IBM. So they, at the time, I think they might have just lost their fastest computer in the world status.
Oh, wow.
They were doing, I think, about 12 teraflops. And this machine in here does about 2. And didn't cost anywhere near what those things were.
Yeah.
It does a gigaflop. I got it up to a
That's not even teraflop.
gigaflop. Yeah, that's it. It doesn't even do, it does 1 gigaflop, that's it. So,
I think if you take advantage of all the GPUs in parallel, it's supposed to develop out 2 teraflops.
that's most I got is a gigaflop.
Yeah.
Even using everything it has. So,
What about the lab in New Mexico? I'm curious.
There were 2 of them. Los Alamos was one of the big ones, and they were running Origin 2000 SGI computers. Very interesting machines. The memory layout, I think each machine had like 128 processors, and it was a NUMA layout, a non-uniform memory access. So each processor had local memory, but could directly access memory from any of the others. But it would be slower to do that. It was faster to access them closely. And Sandia National Labs, which I was probably, I spent the least time at, it was probably the most exciting because they were using inexpensive processing power. They were using DEC alphas. And I think they were looking at, I believe it was 5,000 nodes. Each node had a dual processor. Each machine had a dual processor. And we're generating speeds comparable. They weren't as fast as the other 2. They were comparable, and they were looking at, like, I think about a 10th cost
Yeah.
at the time.
So it's really efficient.
Yeah. I'll go back through a bunch of this stuff. As I said, this is my 29th and a half year. And you can take out 5 years. I got seniority even though I was gone. I was in graduate studies. At Lock Haven, I did serve as the chair of the department from 2002 to 2005. I was responsible for the Linux lab, summer workshops for high school students in Linux sysadmin and C++ programming.
How did those camps work? Because I was going through a lot of the old materials that are on the thing website, and I saw some of the old like static pages with like the old like Linux camps. How did that was like actually like a camp out?
It was called a camp. The students stayed in dorms.
Okay.
They were here for 1 week.
Okay.
So we fed them and had them put up in regular dorms, gave them a taste for college.
Yeah. Well, it was like the average. It was obviously high school. I couldn't really gather that from the.
They were supposed to be juniors and seniors. I think they might have had a sophomore. Dr. Pillai is using camps right now, but they're for middle school students, and they're don't even stay on campus. They come in and go to the workshops and then go home and come back the next day,
Yeah.
which would be appropriate because these kids are young.
A little bit, yeah.
Yeah. My goal was to recruit students because when I was I think I was a junior at Bluffton College, I designed and held a camp for high school students, juniors and seniors, high school. And they came to Bluffton College and learned to write Fortran programs. 1 week. And I think I had, I have to guess, I'm going to say it wasn't a lot, maybe around 11 or 12 students. And more than half of them went to that college. Yeah.
Any results for the camps that over here?
Weren't nearly as good.
What is it, I'm guessing it's from like Central Mountain, local schools.
Yeah. And it would be nice if we could attract more people. But our environment's way different. When I went to college, I was very interested in computers. I got a math major as an undergraduate. But I went there and really wanted to work on computers. They didn't have a computer degree. And I got involved with computer my first semester there. But the main reason I was interested in computers was because everyone in the world believed that I knew they were magical machines.
It's still true.
Only now people don't realize they think of them as magical machines. It's just so common. Back then, it was just a new thing. So, I have a little bit of history on one of these slides coming up. Actually, more than one of these slides coming up. This is a difference engine. It was designed hundreds of years ago. I think it was in the 1800s. You're not still recording.
You're fine. Don't worry.
Yeah, you can see this in California. Mechanical. Go to the next one. Unless you guys want to watch.
I remember this picture.
This was the ENIAC. Developed at Penn State. I think the ENIAC was one that I'd read about that, I want to say it had 10,000 vacuum tubes in it.
You showed us this picture on your slides in Conference 15.
Yes, I did. Do you know what a vacuum tube is?
Sure. Not anymore. I remember you were talking about it.
It's a little glass bulb. They're usually about this tall and about that big around.
That's the one for
with
the
some
edge.
pins on the bottom. And it's the equivalent of a transistor, except it draws way more power and is far less reliable. The stories that I heard about this machine was it was 100-foot long, 10-foot tall, and 3-foot deep. It broke down once every 5 minutes, approximately on the average. And the story I heard was they had somebody behind on roller skates, skating back and forth, looking for burnt out vacuum tubes, because they light up. Yeah. Another one of the things on those early machines, they also used relays. You guys know what a relay is? Essentially, a relay is two contacts with an electromagnet to pull them so they make a connection. It's a switch. These machines had some of these in them. And one time when the machine broke down, it broke down because a moth got into one of the relays. Thus, computer bugs.
Is that really where that comes from?
That's my understanding.
Wow.
I wasn't there when it was made, but I did read that that's where it came from.
There's a bug in my computer.
Yep, there's a bug in the computer. I worked at a company called Triplet after I got out of graduate school. When I was an undergraduate, I worked as an engineer there. I did a variety of different jobs. This was an electronic test equipment manufacturer. Had some of the best equipment that I've ever seen. Did not keep up because everything's gone digital. All of their things, they did have a digital meter, but basically they were an analog meter movement. And I should have thought to bring in a meter so you guys could see what it is. Essentially, it's just a device that has some kind of a scale in the front and a needle, and when you hook electricity up, the needle moves and tells you the voltage or the current or the resistance.
Yeah, my grandpa has a bunch of those, because he's a electronic engineer, so he uses that thing all the time. When something breaks, he's always using that.
I love them. I just soon use them as, I prefer them over digital, very much.
My dad's the other two.
Can you tell me why I prefer one of them over digital?
Because, well, depending on like water damage could happen too, besides just like electronic things. That's what my dad always yells at. He's just like, he'd have like a digital one, but my dad's stupid and will like leave it out on top of the hood of a car so it'll get rained on and then it's broken.
Well, I have other reasons, and that is when you hook one of these across a 220 line and it's set on 60 volts, if you're looking at the meter, it starts going real fast when you unhook it before you break anything. The other thing is a digital, your electricity has to become stable before you can read it. With the analog, you can kind of see what's happening. And I actually worked, one of my jobs as an engineer was designing the dampening circuits. They actually had me writing some programs at one point. Dampening, a very simple example of dampening would be if you have a weight on a spring and you drop the weight, it goes down, comes up, goes down. Dampening is how long does it go until it stops. With the meter movement, you want the needle to come up to where it belongs. And if you use a second order differential equation by putting some capacitors into the circuit, you can actually design it to come up and stop. But we don't want it to do that. You actually want it to come up and go past where it is and flutter back and forth and settle in. Otherwise, people will believe they have a sticky meter that doesn't work. So it is very interesting. I went from engineering, and after I graduated, I became a programmer. I might add that while I was an engineer at Bluffton College as a student, I wanted to take an assembler course on an IBM 360. And so I arranged with Triplet to let me use their computer. And the manager of the computing department actually gave me a couple lessons in assembler, and that's where I learned assembler. So I became a programmer then, programming an assembler. He wound up hiring me. And eventually I got promoted to systems programmer. There was still only one of me. They just changed my title. And actually while I was working there, I think it was while I was still in college when I started doing some of this, because I remember the engineering department borrowed me back to design a scale for an edgewise meter. An edgewise meter is one that sits like this and has a needle that comes out this way. And it was an interesting problem. I can tell you guys about it because I was also successful. The needle movement had a radius. The scale had a different radius. And the glass front that had a curve on the inside had a different radius on the curve. And light bends when it goes through that glass. So designing the scale, you had to take into account all the different radii and where you're looking and how the light is bending in the process. So it was actually a very interesting problem. I did work as a programmer, an IBM assembler, did a lot of A lot of assembler programming. I would venture to say with a week or two of review, I could probably program as well as most people in IBM 360 assembler, 370 assembler today. Because I did it for a long, long time.
Man.
The IBM 360. We use something called Hollerith cards, also known as IBM cards, where you actually had a key punch.
So,
I actually had one, a little handheld mobile one, that of course it didn't print on it, but you had to punch, if you wanted the letter A, you had to punch 2 buttons, you had to know which buttons to press to get the letter A.
so do you have like a typewriter-like device to punch these? Or?
That's what we usually use, something that looked a little bit like a typewriter.
Okay.
And you learned lots of tricks, because once you made a mistake where you put an extra space in or something was in the wrong columns, it had a duplicator feature. And you learned to hold one card and let the other one advance so you could adjust your columns back and forth. This was a unit record processing machine. If you had more data than would fit on one card, basically used one column in a card to say, well, this is card number 1 or this is card number 2. And you'd put all of the data together by accumulating all the different cards coming in into a full record and then put it into the computer system. But yeah, I had nightmares with these cards. When I was in graduate school, that's what we used at Bowling Green State University. It was ugly. This is an IBM 360. This is the central processing unit. We didn't have tape drives, we had disk drives. But this machine back here, which is the same size as this, and they were, I want to say around 6 foot tall and about, I think, 6 to 8 foot deep and a couple foot wide. This machine handled all the input-output. And the IBM 360 was one of the first machines that allowed you to overlap computation with input-output. They actually had, you guys should be aware of the computational abilities you have today. Are your disk drive controllers? Well, that's what that was. It was the controller, which allowed things to happen during computation as far as input and output. These are disk drives. When I gave the talk, I probably took in the disk drive.
It was huge.
Yeah. The ones I used had 5 megabytes of storage. They were removable. You could push down on this little lever in the front, the lid would come up, you put down a cover and unscrewed it, or actually screwed the disk onto it, pull it out, put a bottom on it, set it aside, put a different languages. We had a network definition language. Our network communications, 9600 baud. 9,000 bits per second. And our terminals were all character terminals, 1,900 characters. I think we had, might have had 50 lines, 40 or 50 lines by 80 characters wide. And so sending a whole screen full of data took some time. The network definition language was used to define each of these. When we bought this computer, we converted every piece of software from an IBM 360 assembler, which was designed to do strictly batch running, take a whole bunch of cards, run them through, update or whatever it's supposed to do, get your next batch of cards. And we changed to almost entirely interactive terminals. When I left, I think we had around 20 terminals, it might have been more than that, 20 CRTs. We eliminated 4 positions in the computing center. I think we had 4 ladies in there doing key punching. And unfortunately, most of those ladies left. We didn't want them to. They said, well, you're going to get rid of this job. Yeah, but you're needed somewhere else. You're going to be doing data entry on terminals directly at the point of collection of the data. And they all left. And as they left, we didn't bother to replace them. So the interactive terminals, I remember when I was doing the development on this, we had some visitors from one of the colleges, and they said, what accomplishments have you made? And I said, well, we changed the time to process a batch of sales orders, which used to take a week, was way too long, and so they created a rush order, which they do in 4 days. And after we were done with this, they didn't bother with rush orders because we processed twice a day, 4 hours to process all the sales orders. Very, very interesting. I learned a phenomenal amount working at this company, not only as an engineer, but as a programmer, software engineer is what you call them today. And well worth my time. If you guys want to learn a lot, go to a small company where you have to do everything. That's really what I did. Wrote portions of the operating system, added to the operating system on the Burroughs. Had written it in COBOL. So when you hear how terrible COBOL is, I will warn you, those people have no clue what they're talking about. COBOL's a very nice language. You compare it with today's languages, you guys will think it's very limited. There's no recursion, which I needed, so I implemented it in COBOL. There is no local variables. Everything's global. There is no runtime overhead. Your entire program is loaded, all your data is loaded, it never changes in size. No extras are needed. Very fast. Fortran was the same way. Today's version of COBOL and Fortran, which I'm not familiar with anymore, I suspect are different. I know there's an object-oriented COBOL now, and Fortran was touted as being somewhat object-oriented or adding some of the features. So, I had to add recursion? How many of you guys hate recursion?
I love it.
Yeah.
No, that's good to hear. Anyone who took my Programming 1 and 2 class always hated it. Yeah.
I was just Josh complaining.
Just Josh. He's gonna hear that one minute.
Yeah, well,
Hate that guy.
I left Triplet in 1981 and went to South Georgia College as a full-time teacher. It was a 2-year college. They were running a Texas Instrument, I want to say it's a 990, I can't remember the number. It was a mini computer, very interesting architecture. They tried to do the same kinds of things that IBM was doing. They actually had a mini computer that came out, it was called a 9900, same numbers, it just added a 0. Had the same instruction set. It was just slower. I taught all of the programming classes, plus some introduction to computing classes. I was only there for 2 years. I left in 1983. And of course, that's when I came to Lock Haven College. It was not university. I don't think it was called Lock Haven Teachers College when I came. It was at one point. At one point, I think it was called the normal school. I think this building was the normal school. We taught a lot of elementary education.
Wow. How big was the campus back then?
There was no East Campus.
Yeah. That was still a high school, probably.
When I came, Zimmerly was here. All the dorms up on a hill were there. And of course, the new dorm over here was not.
Yeah.
But most of the buildings
Like, so,
locally
yeah,
were here.
interesting.
Now, they've added on the parking lot and other things on the other side of Zimmerly. Those were not there.
When did it actually become officially a university?
I was afraid somebody would ask me that. I don't remember the year. I want to say it was the late 80s. I think it was the late 80s, maybe around 88, 89. I invited my wife to come since she was a student of mine here. I think it was a university when she was here, but I can't remember when she started or when she graduated. And it would have been fun to have her come in and talk, because she's still mad at me. We didn't date until after she graduated. And she said, if you'd married me while I was a student, my tuition would have been paid for. Lock Haven had an IBM 370 when I came. They replaced it with another 370 called an IBM 4341, I think. And I think a year later replaced it with an IBM 4381. It's still 370s, just different models of 370s. And eventually replaced the mainframe with mini computers, IBM machines running AIX, which is IBM's version of Unix. I think even before we got the AIX machines, they had put in an IBM PC lab. It was actually where the lab's at right now over in Robb. They put in a bunch of machines. I think they might have had dual floppy drives. 5 1/4-inch floppies. And the doors were always locked. So I fought with them forever, managed to get some classes running in there. I actually used those machines, I think, when I originally taught the first course in Ada. Ada is a programming language. And they evolved. We got the lab up here eventually, which was dual floppy drives. And I finally got some things organized so that they would work up here. And finally, the IT department did take over and started making things work a little bit better. So the servers were eventually replaced. These IBM AIX machines were eventually replaced with IBM PC-based servers, Intel-based servers. And I think that was in the 90s. I left Lock Haven University in 1995. I took a educational leave of absence, which means my seniority accrued, and went back to Mississippi State University to work on a PhD. I spent about 2 years in classes, and I finished my proposal and started my dissertation, my research. I returned to Lock Haven in '99 because they wouldn't give me another year that I needed. I came back, and that's when this lab was set up. I got the grant in 1999 to do this lab. This was actually set up in the spring of 2000. And I was the chair of a search committee to replace one of the faculty members. We managed to hire Dr. Strayer. And she was very angry with me because, I guess a little bit of history, her husband Jim Strayer and I had an office together over in Robinson Hall for years. So I knew Susan for a while. And immediately after hiring her, I left. And went back to Mississippi State University for another year, where I also was working as a consultant with a consulting firm there, and that's when I was working at the DOE labs. And I returned in 2001, because that was the limited time they were going to let me take off here. And that's about the time, it was, I think it was the day before I was returning, my advisor asked me to change my dissertation topic. So that kind of ended my my PhD work.
What was your original topic? What was the scope of your research?
My research was an attempt to use artificial intelligence and high performance in parallel processing to divvy up work, finding solutions, and put the solutions back together. And I just got together with one of my old friends from Mississippi in October, and he informed me they were using that stuff in some of the disk drives they're now using, clustering disks. They were using the stuff I was working on in my dissertation.
Yeah, they actually didn't change that. Considering how big data works now, that's like exactly.
Yeah. Well, we were processing huge amounts of data then. It doesn't sound as big today as it did then. But I think I mentioned to someone that I used SED, S-E-D, with regular expressions, to reformat one of the data files that was about a gigabyte. Back then, a gigabyte was big. And rather than writing a program to reformat it, I used SED.
So did you send that through a polyphase merge sort?
No, I did not. I sent it through a canned program that did clustering. And I can't remember the name of the program now. There's one that commonly I have students write called K-means clustering. And clustering is basically a way to take multidimensional data and try to group it in groups of where they're closest to each other in the multiple dimensions. Well, this did it, but not with the same statistical method, more with the probability method. And I was probably a very odd research assistant at graduate school. I remember in one of the meetings, my advisor, head of this group, said, does anyone have any questions? You know, and I'm looking around and I said, I don't understand the formulas in the probability. Well, she couldn't explain it. Nobody else in the group had a clue. And at one point she was going to have the author come in and talk to us, but she never did. That would have been cool. But it was some pretty high level mathematics in probability theory.
And that was so it wasn't just like flat data, you had like 3D data, I guess. So the things you had.
I think we were looking at about 100 dimensions.
Wow.
Yeah. Yeah, it's one of those things that I don't think anyone in our world can visualize it.
Yeah.
But dimensions are something that follow rules. So if you comprehend how to go from 3 to 4 and from 4 to 5, you can go from 100 to 101, and it's no big deal. It's just a little more computation. So I came back in 2001. I became chair of this department in 2002, which is also when I took a motorcycle trip. My wife, Diane, had never been on a motorcycle before, and I said, I'd like to buy one. She said, well, go get what you want. We're still married. Her first motorcycle ride was from here to Ohio to visit my family. Her second motorcycle ride
Wow,
was from here out west of Montana.
Oh, wow.
Glacier Park, we actually went on out to Idaho. Yeah, it was, that was summer 2002. Brand new motorcycle. 3 years later, I was very happy to relinquish my chair position. My last year's chair was very discouraging. I had classes start the last week of August.
Yeah.
On Wednesday, before classes started, we had an accounting professor scheduled to do an overload, and he sent me an email saying I quit.
Oh. Oops.
And I got all of his classes covered. And then our wonderful union, which I dropped out of after that, said, you have 2 different managers, each teaching one of your classes. That's not good. We won't let you do it.
Well, then you have no classes.
The other 3 were covered by overloads within our department. But those 2 were important classes, and I finally went to the union and I said, look, fine, we'll cancel the classes. I'm going to advertise in the newspaper that these kids can't graduate because you wouldn't let these classes be taught. At which point, they let our brand new president, Keith Miller, taught a class in business. That was his background. And Corey Myers, Dr. Myers, taught one of the accounting classes. She was the assistant to the president. And at the end of that year, I was very happy to no longer be in an administrative position. And went back to full teaching mode. A couple of years after that, we had hired Dr. Pillai, and I think it was his 2nd year here. I talked him into taking over admin of the Linux lab. One of the smartest things I ever did. He has done a great job here, way better than I was doing. And it was about this time, I can't remember if it was 2009, 2010, I bought 30 acres from my in-laws, half of their farm. And I have a barn up out there, and I am currently out there working, doing wiring and putting up walls and ceiling and other things.
polishing the Harleys.
And my Harley is parked in my barn. I do have some of the wiring done, so I have a maintenance charger on the battery. And I bought a tractor this past spring. And then this year, I became a little discouraged with administration, and in October I decided to retire, taking advantage of getting out before our contract is settled, which may actually cause a lot of damage to retirees. I'm hoping it does not, but
Probably a good idea.
yeah, I'm thinking I'm way better off to retire. Sorry, guys.
Disappointed I don't get to take the
Architecture.
architecture class.
I was really looking forward to that.
We could
I
always
think we had a lot of really good students that were interested.
just get
Just do it in your barn.
I was gonna say, we'll just come to your barn, bring the Linux lab. I have a truck.
just show up here in the Linux lab every so often and start talking
In
about
class, the guys pitch in for dinner every 3 days a week. Put up some walls in the barn.
Talk about architecture.
You guys need to bring me a smart board.
You want a smart board?
We can do that.
Yeah, I know where you
When
can
I
get
teach
one.
computer architecture, a smart board is a requirement.
Oh
Yeah.
man, yeah. How many diagrams everybody was drawing during that time?
Yeah, and the smart board is wonderful because you can draw a diagram, and architecture is a lot of building blocks. You draw one, get it nice and neat, group everything together, shrink it down, duplicate it, and start your next steps. It's really wonderful using a smart board. A little bit of history, progression of computers. And this is an old one, so I haven't brought it up to date yet. But back in the late 70s, I think 78, we bought the Burroughs, I think it was in 78 or 79. So at the end of the IBM 360, it was a Model 22, which is really, they called it a stripped down Model 30. We were looking at $60,000 a year to rent this computer.
Okay.
It ran less than 1 million instructions per second. It had 5 disk drives, each one about 5 megabytes. Access time is about 7,500 milliseconds. We had 24 kilobytes of RAM.
You never need any more than 24 kilobytes of RAM.
Oh yeah, we wanted more.
Somebody made a quote like that. You'll never need more than 24 kilobytes of RAM.
I would make the statement today that you guys don't need, you could deal easily with 1/10, maybe 1/100 the amount of RAM that you have.
Oh yeah.
The problem is, if you got the RAM, you have sloppy programmers.
And Windows.
We wanted to rent another 8 kilobytes of RAM. They were going to charge us $800 a month, so we did not. Ugly, ugly code. I mean, I had programs written, we did a whole business on 24K of RAM. I had programs written that, depending on what the program was going to do for the duration of the execution, it would take this set of code for the other part of the execution, which is never going to be done, and used it to store work areas for input and output of disk files and so on. Ugly, ugly code. I hope to never have to do that stuff again. Today, 2011, okay, this was a year ago. Intel i7 quad processor, what are they today?
Depends on what, like, what.
2.4
Oh.
gigahertz?
No, 3.9.
Yeah, just say.
3.8, 3.9
Yeah.
for the faster ones. I mean,
Is
you
it
can
3.2?
you can overclock them to like 4.9.
Well, you were saying what the servers when they first kick up, like Feathers?
Yeah.
Like, what, like 6 gigahertz when they...
Well, I told you guys I made one of these workshops when I was a student,
Yeah.
college student. Well, the reason was, when I was a junior in high school, I went to one of these workshops at that school. And I really liked the teacher and the fact that they had that. So I actually saw computers when I was a junior in high school, with the cards. And you think that IBM was bad, you should have seen the NCR Century 100 we were working on. It was much worse. But, so I had a 1-week workshop, and so I decided I wanted to go to college. I was, you know, a country boy. I was the first member of my family or extended family, I don't know how far out, to ever go to college. And I had no intention of going to college. But I went to that workshop, and I said, I want to go and do stuff with computers. So I went to that college, and I did like math. And they didn't have a computer degree, so I majored in math and took every computer course they had. I think that was 2. And did several independent studies and study elsewhere. But majoring in math, I decided I'd also pick up some physics courses. And my math and physics professor, he taught both, wanted me to go to work at Triplet in physics. And so when I was a student, I think a sophomore in college, I actually started working at this company in the engineering department. I did several different jobs as an engineer. I was a dumb kid. And all the people I worked with were really good. Now, let me rephrase that. A lot of people put up with me, and the ones that didn't, I kind of ignored. I actually, after I went to work full-time there, I remember my boss came in one day and said, "What did you say to Joanne?" Well, everybody called her Joe. I said, she came into my office and asked why this program generated this output. And rather than let me explain what they were doing, she sat down and complained for the next 10 minutes, and I told her to leave. I was fortunate. I got away with a lot of stuff. But the end result, that company, when I left, had no programmers. They hired one, I think about 6 months after I left. And I expected, I don't know for sure, but I expected to take him close to 6 months before he would be productive and actually be able to write anything.
So they were down for a whole year.
They didn't need one. Everything was working. The last day I was at that company, I stayed late, I think until 7 or 8 o'clock. And all of the office that were involved in the project I was working on stayed late because I was leaving the next day. And that company paid me for a month after I left. So I was quite pleased.
Yeah.
Unfortunately, the company has closed down. That was a disappointment. But soldering machines, not soldering irons, yes, I had one of those too. But they have what was called a wave solder because they develop circuit boards and different things. Antique stuff in today's standards, but it was cool. To actually see them work. They actually had their circuit boards, which they etched, and then would run through some rosin, and then run through this vat, kind of skidding across the top, a vat of molten solder. It was cool. So I don't know if you guys have ever visited the Penn State, their nanotech facility. If you ever get a chance, you should go through that. Nothing like this, what I just described, but it's also very interesting. And they keep talking about all these phenomena. We're now using nanotechnology. And I went through their facility and I'm saying, well, how is this different than any other integration that we've been looking at? You know, the large scale integration, the very large scale integration, small scale. How's it different? Well, you could never get these distances that close before. How's it different? And basically, as nearest I can tell, it's just they're doing a better job. So it's not really a new technology.
It's kind of a buzzword.
Yeah, it's a buzzword. Language changes. When I was your age, computers were rated first generation vacuum tubes, second generation transistors, third generation integrated circuits. And eventually they said fourth generation large scale integration. No, it's still integrated circuits. I'm still waiting for the fourth generation. And now in today's world they no longer call it that anymore. Mini computers, microcomputers were called that because of how many bits could be operated on at one clock pulse. So we were dealing with the original IBM 8086 was an 8/16-bit computation. If I remember right, it had 8-bit data path access to memory and internally would do 16-bit computations. And of course the definition of mini computer was anything less than or equal to an 8-bit processor. Mini computers were 16-bit processor and mainframes were 32-bit. Well, today you never hear those terms. They're no longer appropriate. Everything we have now, anything new you buy is going to be 64-bit. Francis, more questions?
What was your favorite time period, like some of your best years out?
Best years of Lockheed.
Is that even possible?
When you came, for instance.
And if you
I-
say now, I mean, I don't think it's not the best time now compared to probably way back in like the late 80s.
You know, define what it means as best time, because I've had a lot of good times at Lockheed throughout my tenure here. When I first came, they put me in an office with a mathematician named Ray Whitney. He's been going long enough, there's nobody here that's familiar with him. You talk about a crazy mathematician, he was a crazy mathematician. One of the smartest guys I knew in math. I sat through all of his calc classes to do a refresher. He's my office mate, nice guy. After he got to know me, he decided he liked me okay. And he would come up, put this big equation on the board, and he'd walk over, he'd look at it, scratch his head, and write down 6. You'd spend the next hour going through all these equations, and if he got done within the hour, the answer, of course, was 6. And once he got to know me better, he wanted to learn programming, so he was doing all kinds of crazy things. He wrote a program for the IT department back then on the mainframe. They were doing some kind of random number generation for seniority list, I think. And he used 3 different languages to do what would have been done in the simple 5-line program. Including, I think one of the languages was Fortran, one of them I believe was Snowball. I don't even remember what the other language was. But he wanted to do crazy, can we do this type of things. So I had a good time then. Dr. Jim Strayer came a few years later, and Ray Whitney moved down the hallway, and Jim Strayer was my office mate, another mathematician. And we got along great. So I would say probably my least favorite time was in the mid-90s before I left to go to Mississippi State. And right now, I would say I still like it here, but I need to get out of teaching and go into industry. One of the comments I've made, you may have heard this before, every professor should have to work in industry 1 year out of 6. Because we can bring stuff back to the classroom then that is current. And I haven't been in industry since 2001. It's 11 years. It's time that I did something different. And plus with all the other things going on, yeah, it's a good time to leave. Can I answer your question?
Yeah. I have 2 more.
This guy.
What was your favorite course?
Darn. Stay.
Okay. That is my favorite course. Programming courses, I would say data structures is great. Dr. Polite loves that course. And I have no problem. He's admitting the Linux lab. Let him teach what he wants. Yeah, I think he does a great job. So algorithms I've never taught here, but that would be a really fun course. Years ago, I loved systems programming and assembly. We were dealing with 360 assembly. You guys might think about this. When I taught systems programming, this is years and years ago when systems programming is different than today. One of the problems they had when I first taught the course was they had to write an assembler program to read machine language and output assembler. It's called a deassembler. And I had a 3-phase project, and I only expected 2 phases of it, sometimes only 1. And as near as I can tell, no one ever made the 3rd phase. But the first phase was just to generate mnemonics with addresses. The second phase was to replace the addresses with variable names and label names. And some people got that done. And the third phase was to do everything automatic without having any additional information put in describing the machine code. And by the way, this problem came about because when I was first working in industry on an IBM 360, they asked me to do some tasks, and I said, well, we need to have random files, and they had no software to support random file access. They had index sequential. A sequential file and index sequential. I wanted to be able to give a record number in a file, it'll give me the record. And there was no software to do that. So I said, well, I better learn how this stuff works. So I wrote the assembler program to turn some of their modules they had in their operating system into assembler code, and studied them and then added that.
Wow.
So it was, I never want to go through that stuff again. It was fun then. I'm too old now. Last question.
What kind of industry do you want to go into? When you say retired,
I don't know if I'll go back to the industry. I don't know what I'll do. I am not ruling it out, but I'm going to retire. So for a little while,
So you're right, it's hard.
Until you get bored.
I'm thinking I would really love to do a road trip this summer. And of course, it's going to depend, because I told you guys I have a barn on that 30 acres. My wife's reminding me that that's really stupid to have a barn and no house. So it depends on when the house is built. If I don't go this summer, I'll go the following. And I'll probably be involved a lot out on the farm and finishing the construction on the barn I'm doing, and then overseeing whatever construction on the house. And I don't know. There's so many things I like. My preference would probably be to work in C or C++, because I really like those.
Have you thought about contributing to any open source projects?
I have not. I have not studied that like I should have, because I've been too busy doing prep for classes that I'm not as crazy about. Roderick?
What were some things that you liked about industry versus education and vice versa?
It's really tough to answer that. The success in industry is a project that works. When I left that company, and they went for a year without having another program written, and they never lost any time, that's a success story. And that feels great. Teaching, all of you guys in here, as far as I'm concerned, this is a success story. You came on your own time for an hour and a half or 2 hours, whatever it is, to listen to an old guy talk. So when I see students, I love it when I see you guys struggling with a problem and all of a sudden, oh, that's wonderful. So I do like teaching. James?
This might be hard to answer, but what's the trophy project of your career?
The chosen project?
Yeah, I mean, what's the trophy project? What's your big thing that you thought was the high point?
Probably with the company. Because we did a complete conversion of everything. I was a young, dumb guy, and we got everything to work. And it worked extremely well. When we went to the Burroughs computer, they sold us a machine with 128K of RAM. Remember, it went from 24 to 128. Wow. Failed miserably because the OS took over 100K.
Oops.
Young, dumb guy, I'm sorry. Same, I would expect you guys to make similar errors. The company doubled the RAM, and it worked pretty well. But developed a standard interface, and really, I did most of the work there. Wrote some programs which we call reporting programs. They were designed for individual tables, and basically would allow you to do what SQL does today. The interface was a menu-driven interface, very much simpler, nothing as difficult, more like the query by example in SQL. similar to that, not identical. And this was in the late 70s, early 80s. I left the company in 81. So we had a young lady who was in graduate school. No, I think she was an undergraduate. She came and worked as a intern with us one summer. Did a great job. Had an experienced programmer come in and work with us. Worst programmer I ever worked with. Followed every rule that we had for what was called structured programming, a new technique at that time. Followed every rule we had, and his code was the ugliest stuff I ever saw. So you cannot dictate quality by enforcing object-oriented programming or any other style. It just doesn't work. You're going to have people that can write bad code no matter what you do. I would say that was probably the one I liked best. The project I did for regulation scanning for a textual database only lasted about 5 months, depending on when you want to call the starting date. I started in June one summer while I was here, and I ended, it was supposed to be done beginning of September. They gave me the data files to look at the last day of August. So I think I finished up in mid to late October. And that was a exciting project. Probably 20 lines of code in there was the most exciting part. Chemical names, hazardous material transportation. Chemical names have prefixes and or suffixes and or dashes in the middle. And I wrote about 20-line search algorithm, 20 to 30 lines, that identified, they told me 100% to pull them out and get the, they actually incorporated that into all their other code. And it was kind of interesting and exciting to do. They told me 100%, and I said, no, that's not possible. You can say it's in the high 90s, but I'm sure there's something that I missed. It's not going to catch everything. But that was exciting too. Rob?
How about for someone who would like to jump around in the industry from messing around with hardware to programming, maybe doing something with database, maybe networking? I mean, what's a good way to sort of be able to jump around and not be classified as like a programmer or an admin?
That's a tough one. I would say what you probably want to do is consider doing something in process control. The company my wife's with right now, Videon Central in State College, write code for video processing, DVDs, Blu-ray, streaming, and of course, she's in software integration, which limits her to software, which she's happy with, because she doesn't care that much for hardware. But working at a company like that, you're very close to the hardware. So whenever you're doing something with process control, and working at a company more like that, her company does everything. They build the boards and then put the software on it. You can you have the cross-pollination, working with those engineers, asking them questions, maybe even becoming an apprentice, switching jobs around a little bit, which I would encourage in that position. As again, Diane doesn't care that much for hardware. She wants me to go there, and her boss actually asked me. I don't think I will. But it would be exciting because the integration of hardware and software is really fun. And I'll be honest, I really didn't get the integration until I was at Lock Haven and started teaching a computer architecture course. And I think it should be required of every computing student.
I'll see you at the barn.
We'll bring beer.
Rather have wine.
Okay, you call it.
Jeremy, shut up.
I actually have some at home I haven't opened yet. I have some white lightning
White lightning.
I'm fine with that.
and some moonshine.
Sounds like it's in a bar.
This is all fitting.
This isn't in my barn, it's actually in my house. I'm going to open it next month when some friends come to visit. I bought it in May.
Where did you get white? Where is that? Is that from
It's actually sold legally. It's down in Tennessee. Gatlinburg, Tennessee.
I know. I lived in Tennessee for a few years.
So you're familiar with that. I'd never seen it before. So I had to buy some.
Gotcha.
I had kind of a fun question. Is there anyone that you have taught either here or anywhere that's had a lot of what you would consider like wildly success, like a lot of success?
We've had a ton of graduates from here that have been very successful.
He's out in Colorado. They've got him doing some GPS stuff in Python. He can't talk about what it is, so I don't know any of the details, but...
Import missile.
You say he was doing stuff with open layers too? Just tell me if it's
That was while he was still here. I think he's doing something completely different now. But, you know, he's getting paid really well. I mean, they moved him all the way out there. They're just paying to put him and his wife up in a hotel just so he can, so they can work there, and, you know, they're gonna pay to move him out. They'll be back here for like 2 weeks.
No, they still own the house in State College, right?
Yeah, they have to sell that, and then
And then
it looks
they're
like
gonna
they're
move out
getting.
permanently?
He was showing me his apartment, so they've got like an apartment and everything already set up
Okay.
and ready to go. So yeah, they're gonna come out here, get everything ready to go back out there over the winter break. But he's doing pretty well. There's a lot of
I would say
opportunity
that
out
our
there.
graduates have done very well. And there are a lot of really high-paying jobs, and there are a lot of jobs that aren't that high-paying. And what you choose depends a lot on you. If I was in industry, I'd be making a lot more than I do teaching. But I make enough, I make good money here. Faculties that say we don't get paid well, that's not true. Faculty are paid well. In my opinion, faculty are paid too well. I could make a lot more money in industry. Could one of the history teachers?
I think you can make a lot more money teaching at other schools too.
That's true. Actually, at Mississippi State, they had a better layout. You were paid, your pay rate was dependent upon your discipline and competency with competency with.
that you fixed successfully?
Thank you. There were some that I did not fix. I think probably one of the most challenging things was learning to use the new Burroughs computer and establishing a standard design and making it work for communications, every terminal to company, and everything looked the same. And setting up the security. So I would say the interfacing, the message passing from to and from the computers and having them go to and from the proper programs. Because we had all of our interactive programs executing at the same time, and the message passing software that I designed would determine what terminal would go to, and when it came back, which one of the programs to communicate with them. So it was like one great big application. Each program did its own thing, and we had to direct the traffic. And that was successful. I also back when we had the 360 series, I know one, probably the most successful one, was not that much work for me. The company had part numbers. I won't erase any of that.
Yeah, I took your exam. It's fine. You notice it's all system analysis design stuff.
Yes, I did notice that. I've not done grading those yet, but so far people are doing pretty well.
Yeah.
Except you, Albert.
Oh. I blanked on some of them. Yeah.
Here's your grade.
52 minus 1,290.
Sounds right. You just failed your college career on one class.
These would be examples of part numbers that we used at that company to identify products. Sorting.
That's interesting.
These are character strings.
What? Why?
These are character strings. The 52 should come before the 152.
Oh, okay.
The 15K should come before the 52. So this was actually when we were still using assembler, and I rewrote it when we went to COBOL using bit manipulation. I added one keystroke to the part numbers. And in this keystroke, I counted the digits in binary up to the dash and put a binary 3 here. And so now the sorting looks a little bit better. However, you're not finished yet because, let's see, I need another one. (152-24) should come before the 152-120, 1, 2, 3, 4. So I did the same process. As soon as I hit the dash, I counted over and replaced the dash with a number.
2 or 3.
Did this with macros in assembler. And of course, there could be more dashes. You went through the entire part number. I designed this. I was currently in graduate school working part-time. I designed this, and it's very simplistic. The effect it had on my position at that company was they started getting their reports in what they called human part number order, and everyone loved me. So,
What happens when you don't get fancy?
Well, that's pretty fancy.
That's
I like that. It's fun.
it turned out being really, now, without having any concept of what you're doing, I don't remember what I spent. I might have been like a week of part-time work. Finally figuring out a way to do it, and it was so simple. It was so simple. And then when we moved to COBOL, I wrote some standard subroutines, and basically whenever a part number came into the system, the first thing that was done was it called this little subroutine called code part number. And anything inside of the system used code part number. Anytime something was going out of the system, you called decode part number, which was really simplistic. Any character with a value lower than a space was replaced with a dash, and you dropped off the first one. It's a little harder than that because there was a question whether you should count the K as a digit or not. Letters caused other problems. I don't even remember how they finally decided to do it, but as soon as you have a standard, it's easy. So that was that was a very simplistic, very young at the time, phenomenal success story. Any screw-ups? What do you guys think?
Oh, yeah.
Probably.
One time I completely reformatted one of the disk files. This is when we were using assembler. And even checked it out, and it was all great. We kept the backups for like 2 weeks, and then we got rid of the backups. And the next day someone said, all the quantities are one. 200,000 records,
No backups.
Nailed it.
no backups. They took all the source paper documents to another company to have them re-key punch all the data, and we re-entered all of it.
Time to go on a road trip.
The company was nice, they kept me.
Keep your backups for longer than 2 weeks.
Yeah. So, I had done a reformat to make everything run faster. It did run much faster. It also had fictitious data. All the quantities were bad. You know, you're going to screw up. And hopefully what you guys are learning is to maintain backups. The cost of backups today is cheap. With that flash drive, it's an 8 gig flash drive. What do they cost now? $6 or $7?
You said I got my 32 for like 26.
$26 for 32.
What, a bunch of 4 gigs for one each?
$1 a piece.
Yeah. They were Sony, and it's like, whoa, I'll take 6.
Yeah. So, I mean, I was looking at a 3 terabyte drive that connected to the Thunderbolt port on my Mac, and it was like $150 or $140. I did not buy it. One of the things is it does not come with the cable. Have you looked at the price on Thunderbolt cables?
You can go to Mono Price, you can get them cheap.
The cheapest one I found was $50.
Yeah, I'm going to stick by Mono Price makes their own cabling, and they don't charge like those, you know. I mean, now you can get HDMI cables for cheap, but you know, back when an HDMI cable was like $50 everywhere else, they were selling for like $6.
Send me an email, I'll look. Because I would have bought the drive to set it up for my backup system. But, you know, what's it going to be like next month? Disk drive's going to be cheaper?
Half the price that you guys
Yeah.
paid for it.
Once the cables become really popular and the supply is met, the demand is met with the supply, you know, $10 for a cable or less. James?
Well, you kind of know most of our backgrounds in here about what we kind of know. What do you think is the best thing for us to learn in the future? And where do you think it's going to be? Or what do you recommend, I guess I should say?
There is a big market, and this is something I don't care for. There's a big market for web interfacing. And I think that there's a big future there. Again, I don't care for Java. Java's okay.
No, it's not.
I don't really care for doing a lot of web interfacing. But I think that that's an area you guys should look at. I think knowing the foundations of computing is something you guys ought to be concerned with. One of the things that's made our graduates valuable are that they had a good breadth and depth of computer science. I don't know if there's that many graduates that's been out for more than 5 or 10 years who are still programming. How long's Josh been out now? 2?
Not even a year yet.
Not even 1 year.
No, he graduated in the summer. This
Just last spring.
so it hasn't even, it's barely been 6 months.
That's right, he took the database admin class
Yeah.
last year. That's right.
But it feels like 2 years, right?
It felt like 2 years. Sysadmin. Again, that's something I don't care for also, but I think there's a lot of potential there. I think there's a lot of bad sysadmins.
Whoa, whoa.
So if you're a good sysadmin, if you're a good sysadmin, that's should be a valuable background. Again, a lot of our graduates, I think, after they've been out, wind up doing less programming. I know I've had a lot of students say, I really hate programming. Well, first of all, you ought to learn to like it. And once you've learned to like it, after you're out for 10 years, you probably aren't going to do it again.
You still have to know it.
You should still know it. Yeah.
And I think everything's getting so abstracted that I think knowing it will become a very, very powerful asset.
So I'd encourage you guys to, if you're not doing the programming track, at least pick some courses from there, and don't pick the easy ones. You're in college to prepare you for going out to industry and learning how to do stuff.